Independent educational content. Views and opinions are entirely my own and do not reflect the official policies or positions of Akamai Technologies. Welcome to this explainer. Today, we're setting the stage for a highly technical, strategic deep dive into the absolute backbone of our modern digital experiences, API performance and reliability. We're going to explore exactly how to architect a solution that ensures your APIs are always fast, consistently available, and completely secure.
As noted on screen, independent educational content. Views and opinions are entirely my own and do not reflect the official policies or positions of Akamai Technologies. Okay, let's dive into this. In today's hyper-connected environment, connection speeds, they aren't measured in seconds anymore. They are measured in milliseconds. You know, APIs are incredibly powerful, but they're also uniquely fragile if they aren't properly supported. When we rely on these programmatic interfaces for literally everything, from financial transactions to real-time mobile app data, the tolerance for delay is essentially zero.
If your public-facing APIs aren't delivered quickly, the stakes are incredibly high. Think of your network infrastructure kind of like a major city's transit system. Unoptimized APIs facing an unexpected surge in demand act exactly like a sudden rush hour with way too few trains. It creates massive network congestion. And this congestion doesn't just mean a slight delay. It directly translates to poor user experiences, immediate revenue loss, and catastrophic system downtime.
To understand how to solve this, here's our roadmap. Number 1, the modern API challenge. Number 2, introducing Akamai API Acceleration. 3, under-the-hood architecture. 4, scaling for unpredictable traffic. And finally, number 5, securing the API origin. Section 1. The modern API challenge, meeting relentless demand. The core issue we're facing is that API request volumes are growing at a truly relentless pace. We're dealing with frequent, sudden spikes in demand that can quickly overwhelm standard infrastructures.
Section 2. Introducing Akamai API Acceleration, the optimized solution. Now, what's really interesting about this slide is how it specifically targets the problem we just talked about.
This brings us to Akamai API Acceleration. This isn't just a generic web delivery tool. It's a highly specialized answer built right on the Akamai Connected Cloud. Its primary job is to take those concerns about reliability, scalability, and performance and take them completely out of the equation. It does this by fundamentally offloading requests from your core origin infrastructures. Let's define exactly what this is. API Acceleration is a solution optimized specifically for API delivery and other small payload traffic. We're talking about predictable, high performance for large volumes of XML, JSON, and other small transactional and programmatic traffic types. It's uniquely tuned for the lightweight, rapid-fire nature of APIs that are absolutely critical to modern application success. Section 3. Under the hood, architecture, the engine room. Let's move to and see how this builds, because we need to look at how the Akamai Connected Cloud actually achieves this level of performance. Here we have the micromechanics of the solution. It relies on two powerful pillars. First up, routing optimization. The Akamai Edge server literally races different routes to your origin to figure out the absolute best, fastest path across the network at any given moment, totally avoiding congestion. And we contrast that with edge caching. Instead of going back to the origin at all, API responses are intelligently cached and served from an edge server extremely close to the client making the request. If we follow the journey of an API request, it's remarkably efficient. The client makes a request, and boom, immediately the edge takes over processing and routing. This offloads the origin server. Then, for the accelerated response, the Akamai Connected Cloud does something incredibly smart. It dynamically determines if compressing the responses will improve performance. If the API uses text formats, it seamlessly applies that compression on the fly, getting the data back to the user even faster. And this brilliantly illustrates why doing all this at the edge is so vital. By pushing the compute power, the caching, and the routing logic to the very edge of the network, closest to the user, we achieve incredibly low latency. We minimize data transfers across the global internet, and we enable developers to focus on building real-time applications rather than worrying about infrastructure limitations.
Section 4. Scaling for unpredictable traffic. Handling the spikes. What happens when unpredictable surges threaten to bring applications to their knees?
When it comes to business-critical APIs, uptime isn't a goal, It is a mandate. Because this solution utilizes Akamai's highly distributed architecture and efficient load balancing at the edge, it is backed by a 100% uptime SLA. Whether a traffic spike is a planned promotional event or completely unpredicted, it guarantees maximum API availability.
Even with the best edge networks out there, origin servers can still fail. That is exactly why origin failover is built into the architecture. If a catastrophic system failure occurs at your primary origin, the system automatically switches to another origin. This includes configurable policies and recovery methods, providing absolute peace of mind that your infrastructure is safeguarded.
Section 5. Securing the API origin, the shield. Because speed and scale mean absolutely nothing if your APIs are vulnerable to attack.
So the crucial point is how we protect that origin infrastructure. API Acceleration uses a feature called origin cloaking via Origin IP Access Control Lists, or ACLs. This acts as an impenetrable shield. It literally cloaks your origin from the public internet, completely removing it from internet-accessible IP address space. Attackers simply cannot directly target your application origin because they can't even see it.
By leveraging the Akamai Connected Cloud, you are fundamentally moving authentication and security away from your origin infrastructure and pushing it out to the edge. Alongside origin IP ACLs, endpoints are secured with standard and enhanced TLS for encrypted responses, token authentication to block unauthorized access, and content targeting to restrict access based on geography. It's a comprehensive, highly scalable security posture for the whole shebang.
I want to leave you with this final thought to really digest. Knowing the fragility of modern, high-speed digital environments, what happens to your infrastructure during your next unexpected traffic spike? I encourage you to reevaluate your current API scaling and security readiness. Are you still relying on centralized origins, or are you ready to push performance and protection to the edge? Thank you for joining me for this explainer, and keep learning.